Hello there, welcome back to Verbose DevOps. I hope you are well. Now today I want to take you through some random interview questions that you would get when applying for a job as a DevOps engineer. I'm going to give you not just the questions but also the answers. So 11 real life questions. These are actually questions that I have received in interviews, and it'll be over multiple topics. Later on I might do some other videos where all the questions are on a specific topic, but this is completely random and it should give you a flavor of what a real interview could be like. Topics from all over the place, some that you might not expect, some that you might even think are unfair, and that's just the way it goes. So I think this is a good preparation, and the format it's going to be in is I'm going to deliver the answer in two aspects. The first is a quick answer in blue, because it's very important sometimes to memorize a concise answer. And the reason is, the more that you waffle and just start using unnecessary words, the worse it can look to the interviewer. So that's what the blue quick answer is about. But I'm also putting something called extra, which is optional extra detail for you to understand, but also if the interviewer asks for more detail, then you can give it. So both are important, but I thought I would make that distinction. So let's make a start. A common one I get now, I've had this several times: what is GitOps? And the quick answer is, it's automation to deploy and maintain the state of Kubernetes resources. A control loop uses webhook notifications from a Git repo, which is itself the single source of truth. Very important. This enables continuous reconciliation between the repo and the cluster state, and in both directions. So let me give you some extra explanation on this. When you make changes in a repo, such as you do some commits, you make a pull request, it gets approved, and you then merge that to main, then these changes, so new manifests for example, are affected immediately on the cluster. But this is the important part about GitOps, because we have that already, right? With GitOps, the reverse is also true, that any unauthorized changes made on the cluster are actually corrected back to whatever is in the repo. The repo is the single source of truth. So common tools that are used for this, there's really only two: Argo CD and Flux. If you haven't already, I recommend you try at least one of them in a test environment of your own. Argo CD, for example, because it's got a UI. Some people, by the way, have an alternative definition of GitOps, and they use it to describe any type of infrastructure as code, that you're storing your code in a Git repo, and then you have a pipeline which will take that code and deploy the infrastructure from there. And some people call that GitOps. Actually, it's not really GitOps. GitOps has this bi-directional continuous reconciliation, and then GitOps is really only a Kubernetes thing, because only in Kubernetes can you have this continuous reconciliation, because Kubernetes is in itself a self-healing platform, and it's got control mechanisms in it. You don't get that with any other platform. So just to let you know, sometimes GitOps is used to describe non-Kubernetes resources, but it's not really, that's not really GitOps. Now I want to show you, by the way, I'll just show you quickly a website here. This is from Microsoft documentation site for Azure, and it has some examples of GitOps, and one scenario here. It has some for Flux as well, and it has more complex ones, but this is pretty basic. And you can see that the developer, stage 1, does a commit to the repo. It's actually more than a commit, really. It's you probably set it up so that it would require a full merge. and number 2 from the cluster is always continuously syncing to the repo, the single source of truth. So when it detects that change, that commit, then number 3, it will deploy those changes thanks to the Argo CD or Flux operator that's in the cluster, and it will deploy those changes. And what it doesn't show there is that if I go in on the command line, run kubectl and start editing resources, then actually the operator will help revert the state back to the single source of truth, which is in the repo, because that's where everybody agrees that the single source of truth should be. There's a whole approval pattern that's used there, and anything that's done manually by someone in the directly on the cluster, it should be corrected, it should be reverted. So I thought I'd show you that. Let's go back to the slide. And let's move on to the next question. So another question, and again I've had this multiple times, and it's what are inodes? Now I think this is a bit of an unfair question because it's very unusual to actually come up on this concept in the real world in DevOps. We're moving away from Linux and getting more to abstractions such as Kubernetes. But anyway, yeah, and even if you're running Linux, you don't often see this. So what are inodes? The stock answer you want to give is inodes are a data structure that describe a Linux file's attributes, such as mostly metadata that is viewable when using the ls command. And there is an inode limit per partition. So what kind of attributes are we talking about? Such as permissions on a file, such as the modification date. So the data in the file that consumes space that you can see as the file size, to store all these extra attributes actually also consumes space, extra space. So as an extra here, I've said that inode limits are determined when the partition is formatted with a file system. By default, the limits are set. It can be changed at that point, but cannot be changed later. And when the inode limits are reached, this is known as inode exhaustion. You may receive a confusing message, no space left on device. And inode usage can be viewed, by the way, using the command df-i, and is often caused by high numbers of small files such as logs and temp files, which you can safely delete, varlog or tmp directory. So here's an example of using df-i. I ran this on a brand new CentOS installation, and so you can see there for each file system you get inodes, which is actually the inode limit. The second column is inodes used. The third column is the inodes that are free. Most useful is probably the fourth column, which is percentage of inodes in use. That gives you an idea. So really what you want to happen is you don't want to reach 100, obviously, because even if you have space left on the disk for files, if you don't have space left for inodes, you can't write any more files. So in general, it's not too much to worry about unless you have a lot of small files, as I say, such as log files or temp files, or there are some scripts out there, PHP programs like WordPress that produce a ton of tiny files, which in my experience have exhausted all the inodes. So that's something to be aware of. So another question I got recently, and personally I think this was a bit of a dumb question the way it was asked. So can we use Sidecar Containers? I got asked this by a manager who really was just in love with Flavor, a tool of the month, that kind of thing, and really didn't know much and asked a bit of a dumb question. I've rephrased this to what are Sidecar Containers and their benefits. I think that's what he was really should have asked. So the answer to this is a pod usually contains a single, for the application, container. A sidecar is an additional container in the same pod used to augment the primary application for many use cases, such as logging, security, enhanced networking. That's very briefly what it is. By the way, that picture there, in case you don't know where Sidecar came from, it is that little extra compartment you get on some motorcycles. You can see why they call it a sidecar. Most motorcycles don't have a sidecar, but sometimes you have a sidecar, you can have an extra passenger. Similar concept. So I put an extra here. The sidecar containers are isolated from the primary container, which is a great thing. They're on their own, but related, but they're on their own, they're isolated, but they share the same network, which is very useful. And really that's the most that you probably be expected to go into about a sidecar. Sidecars are very versatile, can be used in many different things, and many open source products will use sidecars. So it's there, they're available, can do a lot of interesting things. Logging, security, enhanced networking. I got a question as well recently which was more of a system design style question, but a bit of a short one, or a kind of solutions architect type question. And the question was how to build a high traffic static site. And I didn't know the answer to this question really, because there's so many choices, but having looked into it, this is probably the best answer that you could give. And the key here is that it's a static site. It's not dynamic. So you can use cloud object storage, e.g. an S3 bucket. And that's a misspelling there. I said front end, but actually that's fronted. So fronted by a CDN, such as AWS CloudFront or Cloudflare. And then additionally use a framework that supports static site generation, such as Hugo or Next.js. Now, if you didn't understand this, let me explain it. It's a static site and it's high traffic. So object storage is great for a static site, and putting a CDN in front will allow you to also cache the objects in that bucket, so that you don't always have to hit the bucket. That means cheaper, it also means quicker for the end user, and especially suited to high traffic. And instead of just having images and static HTML files in the bucket, that would make for a website that looks about 20 years old. Today you can use a modern framework that supports static site generation, and two really popular ones that are worth remembering. I would even say have a look at the websites of both of these. One is Hugo and another one is Next.js. Next.js does more, but it does support static sites, and Hugo is specifically for static sites. So definitely worth looking into both of those. Now here's a bit of extra. I mentioned CloudFront, which is the AWS CDN, and I also mentioned Cloudflare. Now Cloudflare is a super popular product. It does not only CDN, but it also provides DDoS mitigation and DNS, and really, let's call it best-in-class type service. However, if you don't want to use Cloudflare, you can also use your own cloud. We'll have similar services for DDoS mitigation and DNS services. So Route 53 for AWS would be DNS. I don't remember what DDoS is, but you do have other things such as Web Application Firewall, WAF, other similar services. Most clouds will do DNS, definitely, and they'll do DDoS and web firewall type services. So Cloudflare, though, does all of them. Really great service. Now, next question is, and I got asked this question, and I do think it's a bit unfair, but I do think it's worth looking at this, and improving your knowledge is going to really help you. On a bash terminal, how to open a CSV and sort it by the second column, and then save this to a new file. I hate this question. I think it's really interviewer just trying to flex, and if you've never use these things, then you're just not going to know the answer. But here is the answer. So it's pretty simple for bash. You need to use a utility, a tool called sort. You may not have used that before. And let me run through the syntax here. -t is used to specify the separator or the delimiter. So in this case it's -t, comma, because obviously in a CSV the comma is a separator. And then you've got -k2. What that means is the second column. And then you've got path to your file, so that's the input file. And then obviously you redirect that with the greater than sign into the destination file, which in this case is sorted.csv. And that's how you do it. Now I wanted to show you how to do this in Python, and to do that use the pandas library. And you do need, for DevOps interviews these days, they will test you on both bash and Python. They shouldn't test you on Golang, that's a bit too much. But bash and Python, you need to know and you need to practice both of these. And actually I would say in Python, one of the libraries or the modules you'll be expected to know is pandas. It is used by a lot of data scientists because it's a really nice library to use if you have to manipulate data. However, you're also going to need to know it as a DevOps engineer. So have a look at pandas. It's kind of like, I don't know how to describe it better, but if you need, like, let's say basic database functionality without using something like the MySQL library, okay, put it that way. So the first line, you want to import pandas, and we're going to import it as PD. You don't have to do that, but it's extremely common to import it as PD. And then the next row, and the next line of code I should say, is new variable CSV underscore file, which is going to be referencing the path to the file. Next line, new variable data is going to be PD, which we just imported, it's pandas, dot read underscore CSV, which is a method in that library. So a pandas method to read a CSV, and and then we're going to refer then to CSV underscore file, which remember is the path. So that's in parentheses. A new variable on the next line, sorted underscore data, is going to be data dot sort underscore values, which is gonna, it's a method that's going to obviously sort, and as a parameter it's going to be to sort by data.columns index 1. So index 1 is the second column, index 0 would be the first column. This is just convention for indices, indexes, whatever you want to call them, that the first one is 0. And that's a common convention in Python. And then print the sorted data, that's optional obviously. And the final line of code is that sorted data, that variable that we made earlier, dot to underscore CV, and here we can put in the new file, the destination file, to save it as sorted.csv. But there's an additional parameter which is index equals false, and what that will do is pandas, you see, will automatically create an index in the first column, because indexes are really super useful, and we don't want to save that in the CSV, so we can get rid of that. We just want the original data. And there you go, that is a solution. I know it may be a little bit unfair, you may not be expected to get it exactly. You can just say, well, I'm familiar with the sort function, and I know that you can set a delimiter and that you can specify a column on which to sort, and you can say that you don't remember the syntax, but you just remember that as parameters there exists delimiter, column, input file. They would be happy with that. If you're going to give the pandas answer, again, I think it would be crazy to expect you to reproduce this syntax, although you might get it in a live exercise. And actually, if you have an IDE with autocomplete functionality, or you have access to the documentation, then you could well be expected to come up with this. So just a bit of warning. practice it beforehand in that way. Now, another question you get asked is, where can you find the kernel logs in Linux? Now, you may think it's unfair to be asked this kind of Linux question, but actually you are going to be expected to know where logs are in Linux. Now, I want to just tell you, before I give you the answer here, that the question, it says, where can you find? This is already telling you about location. So that's already giving you a clue about what they want in an answer. Now, a little bit of background first. There's two ways of doing logging in Linux. One is an old, a legacy way, and there's a newer way. The old way was syslog. The new way is journal D. Okay? The old way, syslog, used plain text files that are stored in var log. You can see I'm making reference to them on the page there. The new way, journal D, doesn't use var log. It actually stores them in another location, which I'm going to show you shortly. I think it's var journal something. I can't remember off the top of my head. But they're not plain text files. They're actually binary compressed files. So if someone says to you, where can you find some logs in Linux, they're really talking about the old way, because they're talking about plain text. They're talking about plain text logs that you can go look at, you can tail them, you can inspect them, whatever. They're not talking about the new style logs that are compressed binaries, because why would you be interested in compressed binaries? You can't look at them, you can't grep them, you can't manipulate them or anything like that. So when you get the question, where can you find logs, they're really talking about the old style logs, which still exist quite often. Both of them often, old and new, will be there simultaneously. So let's get back to the question, right? They're going to ask you, where can you find, in this case, kernel logs? That's also another clue which I'll explain shortly. And where can you find logs? A better answer for you to give is not necessarily where, but how you can get those logs. The question is a bit dumb. It's better to answer how you can get those logs. So let's explain it now. Kernel logs can be found using journalctl-k. This is for journal D logs. Or alternatively, using dmessage-k. And this is for syslog logs, which are legacy. Or on Debian or Debian family distributions at varlog kern.log. So varlog, these are syslog legacy style logs, kern.log. This will become more clear later. And as an extra, we're now going to go into the extra explanation. As I already mentioned, legacy plaintext logs are generated by syslog and within var log. They are, let me show you, this table. These are legacy logs, remember, they're plaintext logs. Plaintext logs can be useful. Any kind of plaintext, anything can be useful, because you can view it, you can grep it, you can open it in Vim, you can search and replace, you can do all these kind of text manipulation or just viewing. So these are old style syslog logs that are stored in var log. Now, there's two types depending on the family, whether it's Debian family, Linux distribution, or Red Hat. Let's start with the first row, okay? Now, I put here a square in blue for the first two columns. Ignore the third and fourth column for now. What's most important are the first two columns, right? You basically have two files. You've got, in the first column, you've got all messages except for authentication, and on Debian that's in syslog. And then you've got authentication only style messages, and in Debian they're stored in auth.log. So let me remind you, all messages except auth are in syslog, and authentication messages are in auth.log. Syslog and auth.log. This is for Debian. Now for Red Hat it's different. They have to do things their own way. right? In Red Hat, all messages except authentication are stored in messages. Still in var log, but they're in messages. And authentication logs are, it's called a file name called secure. So you've got syslog and auth.log for Debian and messages secure for Red Hat. And remember, there's no overlap between all messages and authentication messages, because it's all messages except authentication, and separately authentication. So first column plus second column equals everything. There's no overlap between the first and the second column. Now, remember, we're still on legacy logs, and we're still in var log, and we're still on syslog. Now, for Debian family distributions, there's two other additional log files. One is called kern.log, and another is called messages. Now, kern.log is just kernel messages, and messages is just general non-critical messages. Now, what's their relationship to the main log files that's in the blue square? Well, they overlap. So kern.log, you'll find all of those duplicated in syslog, and messages the same thing. In fact, messages might even contain auth, I don't remember, but basically it's like someone said, we want to make it more convenient. If you want to look up kernel messages, or you want to look up general messages that aren't critical, we're going to take a copy of what already exists elsewhere and just put it in a dedicated file for you. That's the meaning behind it. So when back to the original question, which is where are the kernel logs, you can see that the answer is probably going to be, or what he has in mind, the interviewer, is kern.log, because he's used to using Debian, and he probably used to going to that file location. But actually, if I go back a slide, the better answer, as I've said, is kernel logs can be found using journalctl-k, or alternatively for legacy dmessage-k, and they'll both get the same thing. And it's better than going to kern.log, which is probably what he had in mind, where he really asked the kind of dumb question, to be honest with you. In my humble opinion, not a dumb question. That's a bad way to call someone, but I think you get my meaning here, that it was a badly phrased question, and I think he would probably agree with me. So I put a note here: journal D has largely replaced syslog and uses compressed non-plain text files that are stored at varlog journal, and they're accessible using journalctl, whether you're a human operator or using a script. They're not intended to be opened with, cat or less or anything like that. You can just use journalctl. And I recommend that you want an alternative explanation of this table that I gave and logs in general. I will probably make a future video, but for now, if you just Google for if you go to askubuntu.com, you put in the search field that article number 26237, then you will get a great explanation. That was one of the source articles I used to refresh my memory and learn some more about logging. I will make a separate video though, definitely. Another question I got asked recently is, what is BGP? Just a heads up, this is a networking related question. Now, you don't typically get asked many networking questions these days, because networking, it's still important, but it's less important than it was, and in the cloud especially. In on-prem it's different, it's still pretty important, but not in the cloud so much. But you may get asked a random question like this. I've been asked this by different companies, and it can happen. So Border Gateway Protocol, which is what BGP is, it's a protocol used by ISPs and large companies to exchange route information to ensure that traffic is routed via optimal paths. And just a bit of extra there is that BGP operates at the network layer, so that's layer 3 of the OSI model. If you don't know what the OSI model is for networking, I strongly recommend that you you have a look at that. It's going to be very useful, maybe less so layer 3, but layer 7 and layer 4, you're going to come up against that a lot in DevOps Cloud, because layer 7 is where protocols like HTTP operate, and layer 4 is where protocols such as TCP and UDP operate. And for example, you're going to have that in load balancing. Layer 7 and layer 4 load balancers, often also referred to as application load balancers and network load balancers. So I definitely recommend you get a quick overview of the OSI model if you don't know what that is already. And this is a very common question. I've had this many times over the years. I wouldn't even call this a networking question. This is more a communication question. What is the difference between TCP and UDP? So the answer is that they are both communication protocols. TCP provides reliable, ordered, and especially, this is the most important point, you need to get this in your answer, connection-orientated data transmission. And UDP has less overhead, so it's faster, but it's connection-less and less reliable is probably a better way to say. It's not unreliable, but it's less reliable. UDP is used where timeliness, speed, and low latency are important. And here are some really great use cases that you can use. Streaming audio or video, like YouTube. Gaming, UDP is super popular. You may already know about that from opening ports on your router for gaming. And DNS, by the way, also uses UDP. So here's some extra information, and this explains the above really. So TCP establishes a connection. Before any data transfer occurs, a connection is established, and it guarantees packet delivery. UDP doesn't do that. UDP is send the packet and hope it gets there. It usually will, but it might not. And TCP guarantees the order of the packets. Now UDP doesn't do that. So in theory, when you're streaming video, you might get a frame of video in the wrong order before another one, which actually came before it. And TCP also has some control mechanisms for flow and congestion. However, it's a generic protocol, so if you need really high bleeding edge performance, then I know that some companies, what they do is they don't use TCP, but they still want all the benefits of TCP. So they put that functionality that's in that overhead, they put that instead into their application. And like I said, they use UDP instead. And by doing this, they can actually reduce the overhead, but still keep many of the benefits, just the ones that they want, customize it to their own requirements. A question: design a URL shortener. I got asked this question, and I do think that system design questions, which is what this is, I do think that they're a little bit unfair. So I want to make a distinction here. If you do a basic cloud certification, normally the first one people do is like a solutions architect certification. And the kind of questions you get asked in the exam are, you get given a use case, and you get asked to choose some suitable infrastructure components. And that's solution architect basics. System design is something that developers are more used to. It's a lot more developer orientated, a lot more application orientated. And cloud architects, if they're good, they may end up doing this, and DevOps engineers may end up increasingly being asked to do system design questions. So I hate to say it, but it's becoming more and more common. I do think it will benefit you to learn more system design to some degree, maybe not to an advanced level, I don't know. That's arguable, but you definitely need to know the basics. So this is a system design question. Design a URL shortener. And I will do more system design videos later, dedicated ones, but for now, here is an example. Now, I have made another video on this, and I do strongly recommend you look at it. But here is the basic answer. If you just get asked this and you haven't seen my video, this is the basic approach that you want to take to a system design, a certain question. The first one is, you should always, or it's always a good idea to start with the APIs that are going to be required. So think about a URL shortener. Think about it from the perspective of the person browsing or using the website, or an application that's using that service. Ultimately, there's going to be APIs required. So think about the APIs. What are the APIs we're going to need for a URL shortener? Well, if you think about it, you're going to need two. You're going to need the ability to convert a long URL, convert it into a short URL. And you're also going to need the ability to give a short URL and have the shortener service look up that URL and return back to you the long URL that was already registered in the database. So you will probably be expected to give more details, such as the API calls, what kind of requests they would be, and also what HTTP status codes you would expect. And I cover that in my other video. And I mentioned here just a couple of other aspects that are also in the video that you could mention, and this is more infrastructure solution architecture type stuff. And one is that you'd want a cache service that can return frequently requested lookups, so you're not having to constantly hit the database on the most popular URLs. And I also said there, for the database requirements, you really just need a simple key value store. Any type of modern NoSQL database, cloud database that will easily scale and can handle a high load. What you don't need is a SQL database, because you're not going to join tables or do any other kind of advanced SQL queries. You don't really need that functionality for a simple key value lookups for a URL shortener. So check out that other video. I put what you should look for, URL shortener DevOps system design. It's 12 minutes. Strongly recommend that. Here's another extremely common question. Describe an incident you caused, or describe when you broke production. And it's a very cliched question, and it's a fair question, to be honest, but the only thing I don't like about this question is, what if you never broke anything, right? Then you're going to struggle. So if you're like that, maybe think of just something that is not on that scale but a little bit smaller. Or maybe you did something and you basically in the end wasted 2 or 3 days on this, and if you were going to do it again, you know an alternative way. The key here is, the first point is, how did you react? So especially for a big incident, and the points you want to get across was that you didn't panic, that you took some kind of measured and methodical approach. Something I like to say quite often is, if you're troubleshooting, quite often it's really just a process of elimination. It's also, you narrow down your problem via a process of elimination. And also sometimes you may go for the quick wins. There may be something quick and easy to troubleshoot that could potentially give you an instant or quick solution, and it's always worth trying to get a quick win from the low-hanging fruit. That's more the point I'm trying to make here. Sometimes you troubleshoot some low-hanging fruit. It's always worth doing that than trying to go down some really complicated path. Often it's the simple things, right? And yeah, just say that you're methodical. I would also say that you brought in co-workers as well to get different perspectives, so it's a kind of pair programming or pair troubleshooting. You could even say that you assembled a tiger team, which is really just a group of people from different disciplines who can lend different perspectives and insights. It's a similar thing. Also, you should say that you kept stakeholders informed throughout, and it could be that one person in the team was more focused on the technical aspects of the incident and another person was more focused on higher level and keeping the stakeholders informed. It's very difficult to do both, so I would definitely say that you split the task somehow in that respect. Now, here is probably also, that's more incident management, but what they're definitely also looking for is what did you learn, and the key here is they want someone who is humble enough to learn from their mistakes. Now, I don't know, I'd have to think that you're pretty much not human if you don't learn from your mistakes. So I do think it's, yeah, I don't think the question is great in terms of people looking for this answer, but that you always have to tell them that you learn from your mistake, and this is always something that they're looking for, and it's very common. Even you might get this question with the recruiter. It's quite possible, not only with someone from the technical team, you could actually get it at the recruitment stage. So make sure that you show that you learned something, because that's what people want. Now, final question is, what is the process for establishing a secure connection using TLS? And by the way, TLS is a successor to SSL, and quite often people will just still refer to this as SSL. It's actually, SSL has been deprecated, and it's not correct really to refer to SSL still, but you'll still hear this a lot, so I wouldn't necessarily go out of your way to correct the interviewer, but you can say that TLS is the successor to SSL. It might be quite impressed if you say that. And look, before I give you the answer here, you might be wondering, why is this important? Well, first of all, again, it's communication and secure communication, and we're way past the days when you can just ignore the secure part and the whole certificate aspects. You just can't get away from that today. Maybe you could 10 years ago, but today you can't get away from it. And I also want to tell you that it's not just simple client-server communication like a user in a website where SSL, you might have SSL handoff on a load balancer, for example. That's a pretty common use case, but it's also more important in many other respects as well. So for example, you may have MTLS, which is mutual TLS, being used for your company's API communication. So you just cannot get away from certificates. You may be using, for example, HashiCorp Vault or some kind of other certificate management, maybe your cloud certificate manager. You cannot get away from having some understanding, and this is a great example. So what is the process for establishing a secure connection using TLS? Now the process is called a TLS handshake, and there's a series of steps, and here are the steps. What I will say is that this is a generic explanation, as simple as you can get it really for an interview answer. It does get more complex and it can change, but this is the simplest that you can really give. So the client initiates by sending a hello message to the server, and it includes TLS version being used and preferred cipher suites. And the server responds also with a hello message that includes its site certificate, often called an SSL certificate. It contains a public key, by the way, and also the cipher suite that the server chose. It chose it from your list that you offered it. Okay? Now a cipher suite, I'm going to give you an example later, but it's a lot of different things, such as how many bits of encryption, what type of encryption you're going to use. It's about 6 or 7 different things. And a cipher suite is, let's say, a common combination set of these settings, or of this configuration, because it's much easier if people use conventions and say, well, we're going to use 256-bit AES encryption with X, Y, and Z other parameters as well. So that's what a cipher suite is. It's a collection of configurations. So client said hello, server responds and chose a cipher suite and also with a certificate. Now then, next stage, client verifies a certificate with the certificate authority that issued it. If you don't know what that means, please have a look at that, but I'll give you an example. If I have a website, what I can do is I can use a paid service, and if it's paid, the more reputable it is, the better it is. I can go to verisign.com and I can say, look, I want to buy a certificate, I'm going to pay you a fee, and you as an authority that is trusted globally, you're going to verify my ownership. There's a few ways of doing that. One is to create a TXT DNS record, but there's other ways. And you're going to verify that I'm the owner, and that way, if a user needs to go to you later, they trust you, and because they trust you, and because you've already verified me, then they'll therefore trust me. So that's what certificate authorities are about. So that stage, client verifies a certificate with the certificate authority that used that to confirm. Next stage, client and server do a key share process. This is super complicated, and you can talk a lot about this process, and it can be varied as well depending on various factors. Just stick to saying that the client server do a key share process. The key share process is required to do encryption because you need a key. Next stage, client and server each send each other a finished message, and then next stage, well, we know at that point encryption has been achieved, and therefore the client can send their request with a data payload of whatever they want to do, and at that point it's totally encrypted from end to end. No one can see, a third party, a hacker, or whoever cannot see what is being communicated. So that's how a TLS handshake works. Client and server both do a hello. The client specifies the version and the preferred cipher suite. The server chooses the cipher suite, returns a certificate. The client verifies the certificate to make sure they can trust, and after that there's a key share process. So they have what they need to encrypt, they both tell each other we're finished, encryption is achieved, and encrypted data is then communicated along that channel. So here's some extras. I mentioned already that the above is a simplification of the processes. In reality, it's more complicated, but it also will change depending on the TLS version and the cipher suite used. And 1.3 is the latest version being used, and with it, it's more simplified and more secure. I do recommend reading some articles on this. It has also more efficient handshaking, so those stages I mentioned are actually a little bit reduced using TLS 1.3. Now TLS 1.2 is still supported as a fallback option, and the reason for that is because I think about 60% of websites support TLS 1.3, and what happens is if a website doesn't support 1.3 but your laptop does, then it will fall back to 1.2. And also it's the same thing that maybe you're using, by the way, Windows 10 doesn't support TLS 1.3 yet. So if you're using Windows 10, you go to a website that supports 1.3, it will look at you and go, oh, wait a minute, you don't support 1.3, so we'll fall back to 1.2. That's how it works. There are even older versions out there, which is a little bit scary. 1.2 and 1.3 are the currently used versions. In a couple of years, you won't see any more 1.2. And you can also check if your OS/browser supports TLS 1.3 at that URL there. Let me show you this. I'm gonna pay it a visit. So I'm going to go to the web browser again, and we're going to switch to this other tab. Now if you go to cloudflare.com/SSL/encrypted-SNI, it's got a security check, and it will perform a number of checks, including TLS version. So if I go to check my browser, these are the results, and you can see in that third column there, TLS 1.3, and there's some more explanation if you want it, but there's also some other things there. I'm actually a bit surprised that it says secure SNI. Anybody listening on the wire can see the exact website you made a TLS connection to. It did not say that earlier. In fact, you know what I'm going to do? I'm actually going to go back. I think it's cached that result. Let me press enter and refresh that. And now I'm going to click that button again. Okay, it still says that. So that's interesting. I don't know why it says that. It actually did not say that earlier. That is a topic of research for me to because I'm kind of curious, and it's good to know as a DevOps cloud engineer anyway. So let's go back to the slide, and let's just full screen this. Something else that I also did here was you can get certificate and TLS handshake info by using curl. Now I have another video on curl generally, and you may want to check that out. I think you'll find that interesting. But here's what you can do: curl-v capital I, and put a website there, including the protocol as well. And what I've done here, so capital I is just to get the headers, and the reason I did that is because I didn't want to return the actual web page. Wasn't interested in hundreds of lines of output, so I just said capital I. And the key one there is V for verbose. Now verbose means extra info. It's just like the name of this channel, and in this case we're interested in some of the TLS handshaking and certificate info. So if you look at this, you can actually see there where it says on about the 6th or 7th line TLS v1.3, and it's actually showing the handshaking process. So look at the first line. It goes out, it does a client hello. The next one is that back in comes a server hello. Now, as I said before, the description of the process I gave was a bit simplified. So here you're going to see it's slightly different, but look at the fourth row. TLS in certificate comes in. That's given by the server. Okay, there is some other stuff, but you see there's a row there that says finished, and something interesting as well that actually I see this quite commonly, although you won't normally see this when the process of a handshake is described when you read documentation, but I've seen this a lot, and that there's a change of cipher. So I found that quite interesting, and I'm going to do some research to find out why that is, because documentation typically won't tell you that. And also, if you look there, you can see a row that says SSL connection using TLS v1.3. Great. And it also has a cipher suite there. So it says it's using AES encryption, 256 bits, and GCM SHA-384. That is some other info. I recommend just do a Google for cipher suites if you're interested. It will explain what all that is. And if you look there you can also see the certificate info. So the subject, the common name is the register.com. It's got a start date and expiry, the certificate, and that certificate looks like it's only a few months validity, which is interesting because most companies do about a year. It's got the issuer there and the organization that issued it. Oh, I see why. It's a Let's Encrypt certificate. So that's actually a kind of, have a look at Let's Encrypt. It's commonly used for people with Kubernetes servers, and it's a really amazing service. It's basically allows you to do, it's kind of like self-signed certificates. I may be wrong there in my description, but it's a kind of where you set up your own service to get certificates on demand, maybe a more accurate way of describing it rather than self-signed. So that is using curl to get that info. So I hope you enjoyed all these, running through these interview questions and some concise responses and also explanation. And if you enjoyed that, at the time of making this video, the channel is fairly new, so please check it out. That's where to go. Please visit it. I would really appreciate it. Those are some existing videos that I've made, so I'm on a bit of a roll, and I'm not going to give up. I want to keep making these videos. I'm really enjoying it, and I hope you are too, so please check them out. And thank you for watching. Take care. Bye-bye.